Okay, let's see how we can do the graph of the piecewise function using the graphic calculator. Okay, you press Y key as always, and you write the expression of the piece and the condition of each piece in the same line but separated by parentheses. So you put parentheses. This is a new idea, parentheses. X plus 1, close the parenthesis. This is the first expression for the first piece. And the condition que corresponde with this is parentheses x less than 1. Okay, the symbol for the less than you can get in this key que es called math, pero when you press second, it's this. This is less than. Less than is the option 5. No, less than, no less than or equal. Okay, again, second, this less than is the option, yeah, option 5. Ah, good. Less than 1. Close the parenthesis. Okay, we complete the first piece. The second piece is a constant function of 3, but inside the parentheses, and the conditional for this piece is x greater than or equal to 1, que es the option 4. Okay, ready? And now graph. Okay, you see the graph of the piecewise function. The only disadvantage of the graphic calculator is that you don't see when the circle is full or when the circle is empty. But this is at least good for checking. Let's go to another example, que is the question 20. Okay, let me clear everything. Come back to the y equal and clear both pieces. Clear and clear. Okay, I come back to the y1. The 20 with the expression is minus x plus 3, close the parentheses, and the condition is x less than 2. Second test, less than is option 5. Close the parenthesis. Okay, second piece is open parenthesis, 2x minus 3, close the parenthesis again, x greater than or equal to the option 4. 2. Close the parenthesis. Ready to graph. Okay, perfect. In this case, the function is continuous, exactly as we expect. Okay, the question 21, 22, and 23 are the same. Let's graph the function by starting with the graph of the basic function and then using the technique of the shifting, compressing, stretching, and or reflecting. In this case, f of x is equal negative parenthesis x minus 5, close the parenthesis square plus 3. Okay, this is question 21. I want to do the graph of the given function. start for the basic function. In this case, the basic function is equal y equal x squared, que is a square function. Okay, I know que the square function, the typical point is 0,0, que is the vertex 1, 1, negative 1, 1, 2, 4, 1, 2, 3, 4, negative 2, 4. Okay, this is enough. Now let's do in the graph. The graph is approximate, like that. Okay, the first transformation is y equal x minus 5. Yes, obvious. Square. Okay, this is typical horizontal shift 5 unit, 5 unit, and the direction is to the right because it's minus here. Okay, this is the graph look like that. Now the new vertex no anymore 0, 0, is 1, 2, 3, 4, 5, 0 here. This is 6, 1, then 2,4. Okay, this is our new parabola. Okay, the next transformation is y equal minus x minus 5 squared. Que es obvio que es reflection. Reflection about x axis. Okay, entonces we have exactly the same parabola except que es flipped over the x-axis. 1, 2, 3, 4, 5. The vertex stays the same here. However, it change the sign. Any y value change the sign. Here, here, 1, 2, 3, 4. Here, here. Okay, our parabola look like that. Wow, not good. Nice sketch. Sure. Finally, the last transformation is y is equal negative x minus 5 squared plus 3. In this case we have vertical shift 3 units over, because it's positive. Okay, now finally our graph look like that. So now the new vertex is located at 1, 2, 3, 4, 5, 1, 2, 3 here. This is the new vertex. And of course my parabola open down. 2, 3, 4 here plus. Okay, and this is the final graph. Okay, one important point is, for example, the vertex. In the case of the parabola, the vertex of the basic parabola is located at 0, 0. Here. This, when you are doing the shiftment horizontal to the right, the new vertex is 5, 0. When you are doing the reflection doesn't change the vertex. Vertex stay the same. The only reflection change the direction when they open the parabola, in this case open down. And finally the vertex here is the point 5, 3. Okay. Okay. Let me try to do the question 21 using the graphic calculator. There are two possibilities. You put directly the expression and you get the final answer, or you are doing step by step exactly the same. I want to get you answer in the test. Okay, let's do it step by step. Okay, let's go to the y equal, and you put the basic function. The basic function is x to the second power. Okay, the first step is the horizontal shift 5 units down. So you press, for example, bars key, you select y variable, select y1, and here we have y1 parenthesis x minus 5. It's a horizontal shift 5 units to the right direction. Now the next transformation is reflection. Reflection is minus variable y variable, and you select y2, get the second. After, the last transformation is y3 variable, y variable, select y3 plus 3. Okay, gets the vertical shift. And this is the final answer. So to emphasize this is the final answer, let me change the style. I put like a ball. So this differentiate. Okay, this is the final answer. That we are doing the graph of the every piece. Let's press graph. This is the basic parabola. This is the horizontal shift 5 units to the right. This is reflection, and finally the vertical shift. You see that this is the final answer in bold. Okay, 3 units over. Perfect. Okay, question 22 is exactly the same question, but I change the function. The new function is f of x is equal square root x plus 6 minus 5. Okay, this is the question 22. In this case, es obvio que the basic function que we are using is square root. The typical point of the square root is again 0, 0. Is 1, 1, because square root 1 is 1, and 4, 1, 2, 3, 4, 1, 2, because the square root 4 is 2. Okay, let me draw then approximately my chord. Now, the next transformation is y equal square root x plus 6. This is typical horizontal shift 6 unit. In this case, in the left direction because it's plus. Okay, then the point then is it's negative 6. Negative 1, negative 2, negative 3, negative 4, negative 5, negative 6 here. And this is 1, 1 again. And this is 1, 2, 3, 4, 2. Okay, this is approximately the chord que corresponde with this chord. Okay, the last transformation in this case is y equal square root x plus 6 minus 5, que es obvio que es vertical shift 5 unit down because it's negative. Okay, therefore my new point, reference point, is in 6, 1, 2, 3, 4, 5, 6, and negative 5. 1, 2, 3, 4, and 5 here. 1, 1 is okay. And 1, 2, 3, 4, and 2, 1, 2. Okay, this is approximately my new chord. Okay, so at this point is the point negative 6, comma, negative 5. In this case, and the original, the point is 0, 0 in the basic. And the first transformation is negative 6, 0. Okay, and the last was negative 6, negative 5. That's it. Okay, let me try to check in this problem. So the problem or the question 22 by graph calculator. Okay, I go directly to the y equal. I put the basic function. In this case, the basic function is square root x. let's do it transformation by transformation. The first transformation is you press bars, y bars, y1, and inside you put the transformation x plus 6, x plus 6. And finally is the vertical shift, press bars again, y variable, select y2 in this case because it's a second transformation, minus 5, subtraction 5. And of course this is the final answer. Let me put in bold style. Super. Now graph. This is the basic square root function. This is the horizontal shift to the left, and final vertical shift down 5 units. And the bold curve is the final answer. Okay, the last question, question 23, is exactly the same. Graph of the function using transformation. In this case, the function is f of x is equal, open parenthesis, x minus 1, close the parenthesis, raised to the cubic power plus 7. Okay, the last question, que is the question 23. Okay, for solving that, the basic function in this case is the function y equal x to the cubic power. Okay, this function passing through the origin also 0,0. A typical point is 1, 1, 1, and negative 1, negative 1, because it's typical odd function. Suppose another point 2 is 8, 1, 2, 3, 4, 5, 6, 7, and 8. And likewise, negative 2 is negative 8, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8. Okay, ready. I'm connecting the point by the curve. I know that the curve looks like that. Increasing fast. Okay, good. This is a typical cubic. The transformation number 1 in this case is y equal parenthesis x minus 1 to the given power, of course. This is typical horizontal shift 1 unit to the right because the sign is negative. Okay, now our curve look like similar. Okay, now this point right now is the reference point is here is 1, 1,0, 1, 1 from this point, and 1, 1 from this point. Okay. And the curve is similar. Okay, suppose this point 1, 2, and 8. 1, 2, 3, 4, 5, 6, and 8. Here. And this is 1, 2, 1, 2, 3, 4, 5, 6, 7, and 8. Here. Okay, connecting. Good. Okay. Now, let's see the next transformation. The next transformation is the last. Is y equal parenthesis x minus 1 to the cubic power plus 7. Okay, this is typical vertical shift 7 unit over because 7 is positive. Okay, in this case the point would be 1, 7. 1, 2, 3, 4, 5, 6, 7 here. And this is 1, 1. And this is -1, -1. And approximately the curve look like that. Okay, so now this point, the reference point, the most important point, this point is 1,7. However, in the basic original, this point was 0,0. And in this first transformation was 1,0. Okay, and the last transformation was 1,7. Perfect. Okay, let's solve in the last example using graphic calculator. Okay, let's go to the y equal key. I put the basic function is x to the cubic power, x power 3, enter. The first transformation is horizontal shift, so I go to the variables, y variables, select y1, open parentheses, I perform the shiftment, gets x minus 1, close the parenthesis. And the last transformation is vertical shift, so it's again select vars, y variable, in this case the second step is y2, and you're adding 7 plus 7. Okay, this is the final answer. I put in bold, I change the style in bold to emphasize that this is final answer. Ready to graph. This is a basic cubic function. Okay, this is the first horizontal shift, 1 unit to the right, and finally 7 unit vertical shift, 7 unit over. That's it.